This one is called Section 1-3, Equations. The objective is to find solution sets of equations over a given domain. Now, you might be asking, what is a domain? Hey, you might even be asking, what's an equation? So, we're going to talk about those things. We're going to talk about equations, domains. We're going to have all kinds of cool words, so the new vocabulary that you're going to be able to use in this class. So, let's get started. Let's get it started in here. It's hot in here. Blake, hot. All right, here we go. We're going to talk about equations. Well, so far we've only dealt with expressions, so now we're switching gears a little bit. An equation has something, little thing special about it. Equation, it has an equal sign in it. So what it is actually, it's like an equal sign separating two expressions. All right, it's like in the middle. There's an expression over here and an expression over here. When we have expressions alone, without an equal sign, we either simplify or, what was that cool word? Evaluate. Those are the two things we did. Now that we have an equation, we have to do something different. We have to solve or satisfy, which is both the same thing. Like these equations right now, they're unsatisfied. Something else happens when you have an equation sign, an equal sign in between these things. We can now call this a sentence. And when you see a variable, there's another sentence over here, inside an equation, or in an equation, it's called an open sentence. So what we're going to do is, we're going to try to find a solution. We're trying to solve these. Now, how, you may ask? Well, remember before we did the substitution thing, we took, we said, oh, X might be this, and B might be this, and we threw them in, and we evaluated the expression. We're going to do the same thing here. We're going to try to satisfy the equation. So instead of just saying X equals this, we're giving X is a set, a domain, a number of different things. We're going to, over here, we're saying X is going to be an element of this set right here. It's called the domain. The domain are the things that you're going to plug in for X. Over here, the domain are the things we're going to plug in for Y. So on this side, we're going to plug in 1, 2, and 3 in three different equations. And here we're going to plug in 0 here, and then 1, 2, and 3. And we're trying to satisfy these equations. And what do I mean by satisfy? We want to make the equation true. That's it. Is it equal? Because right now, this is telling me, this equal sign, it's real important in algebra. Everything over here is equal. 5x minus 1 weighs the same as 9. It's telling me. So I'm going to throw things, the domain, I'm saying, when is it actually equal to 9? So that's what I'm going to try right now. So over here, what I'm going to do is I'm going to substitute in these values, the domain, into here, and we're trying to find the solution, or, which is also known as sometimes the solution set. So you'll get it. We're going to go through a couple. Here we go. Ready? I'm trying to solve this equation. And X is an element, X is either 1, 2, or 3. Or it's one of them. The domain is 1, 2, 3. I'm trying to find which of these from the domain makes this true. So let's try 1. It's 5 times 1 minus 1 equals 9. Well, 5 times 1 is 5 minus 1. False. So we know that 1 doesn't work. Let's try it with 2. Let's see, 5 times 2 minus 1. Is that equal to 9? 2 5s or 5 2s are both 10. So 10 minus 1. Yes, true. Now let's try it again. Let's see if it works for 3. 5 times 3 minus 1. Is that equal to 9? 15 minus 1? False. So only one member of the domain satisfies this equation. So this guy is satisfied. See him? Hey man, I'm only satisfied with 2. That's the only time it's satisfied. This is just not satisfactory. 1, 3 is also not satisfactory. So now we can say that solution set is X must be equal to Now the solution set is 2. All right. So you might be saying, well, is it always just one solution? No. As a matter of fact, there are equations with 10, 20, 30 solutions. There's many solutions. Generally, in this class, you're going to see problems 1, 2, none, no solutions at all, and there are actually equations out there that have an infinite amount of solutions, meaning any number you throw in there, that sentence is true. Okay? Next problem. So I look at these two sides of this open sentence. All right? Check out the domain. 0, 1, 2, 3. I'm going to substitute each of those in to satisfy this equation. These braces here tell me this is a set, all right? Trying to find the solution set. I'm trying to solve over the domain 0, 1, 2, 3. That's what I'm trying to do. Y is a member of this set, okay? But I'm not sure which one to actually solve. So it'll be a smaller set that will solve. Let's just get started. Y. Let's try 0. Is 0 times 4 minus 0. Remember, I plug in for both, because now I'm trying, there's a y here, both these y's are always the same. Equal to 3? Let's see. 0 times anything is equal to 0. That's not equal to 3. So, false. Oh, sorry. I made it true. This is false. 0 does not satisfy. Unsatisfactory. I'm not satisfied yet. This guy's saying, I'm sorry, man, I'm just not satisfied. All right, let's try 1. This 1 times 4 minus 1 equal 3. Well, 1 times 4, what is 4 minus 1? 4 minus 1 is 3. What's 1 times 3? It is 3. Therefore, yes. True. Satisfied. Now, let's see if it's satisfied for 2. Let's see if 2 satisfies this equation. 2, 4 minus 2, is that equal to 3? 4 minus 2 is 2, 2 times 2 is equal to 4. 2 times 2 is not equal to 3. So, this is false. This is not equal. This is a false statement. It's not a true sentence. It's false. Unsatisfied. Not satisfied. Still hungry. Looking for a bowl of pasta. Some oatmeal, biscuits, I don't know, something. All right. Now let's try the last one. 3. Is 3 times 4 minus 3 equal to 3? Well, 4 minus 3 is 1. 3 times 1 is 3. Wow, awesome. True, dude. Satisfied. So now this solution, there's two solutions. The solution set has 2 members in it. The solution set to this is a set containing both 1 and 3. Because there are 2 members of the domain that satisfy this equation. The equation is satisfied, the equation is satisfied. Have a very, very nice day.